Hello. Hello, is it audible? Lokesh and Mrinal is still okay. Lokesh also. Right. Okay, let's start now, right? Okay, let's continue now. So we were discussing about what? The projectile motion, isn't it? The 2D motion. So we discussed some example on that, right? So let's continue with that one, okay? Few example we will discuss, okay? Right. And then we will go about the force, okay? The second unit. Okay, should we continue now? Please tell me. So, in the projectile motion we discussed, or 2D motion we discussed, what we saw that if it is ground to ground projectile, then we have some equations, isn't it? Like for maximum height calculation, range calculation, time of flight calculation, when the range is going to be maximum, right? So, all these things, whatever we have done, that was for what kind of projectile motion? For ground to ground projectile, means at what height projectile was projected, the particle came back to the same height again after completing its entire journey. Okay, now the next we are going to have, okay, we have discussed an example on equation of trajectory as well, na? Can we discuss one different type of example where we won't apply these formula? We will write the question. We will solve the question with the help of what? The actual equation of motion. Okay. So let's discuss one example on that. Okay. See, in this example, what is given? There is a tower, and the height of the tower is given as what? 100 meter. And from that tower, a particle is projected horizontally. Okay, how the particle is projected? Horizontally with the speed of how much? 20 meter per second. And this is the ground. So what will happen in this projectile motion? Tell me. This is also an example of what? The 2D motion. So what will happen? This particle will follow a parabolic path or projectile path, and finally it will reach this point on the ground. Okay. So we have to find something in this question, like what is this horizontal distance traveled by the particle? That horizontal distance we are going to call it as what? The range. Second thing we have to calculate is how much time the particle has taken to reach the ground. Okay, that is the second thing. Third thing, when it is just about to land it on the ground, then what is the velocity of the particle? Understood the three thing what we have to calculate here? In this question, find, okay, find first thing is what is the time of flight? Can we apply direct formula of time of flight here? Like 2u sine theta by z? Please tell me. Can we apply that one or not? Second one is the range. And the third one is what? Velocity of particle at the time of reaching the ground. Okay? Or just before reaching the ground. Just before reaching the ground. Okay, understand the question, these three questions. Please tell me, can we apply the formulas what we have derived, or should we start solving this question using the actual application of the equation part? Please tell me. Please tell me, all of you. Sharon, Lokesh, Rashant, tell me.
Sir,
Hello.
we not use to use anti-WT.
Right. Why? Because in that case, it's a ground to ground projectile, then only we can use it. Tell me, Lokesh, Sharon, both of you. Yeah, please tell me.
Shivansh, can you show the questions?
Yeah, question is that this case, the projectile is or the particle is thrown from some height and now it is reaching the ground. It's not a same height projectile motion. Like ground to ground projectile motion is not there. It's a projectile projected from some height and now it is going to land on the ground. So can we apply the time of flight formula or range formula here?
No, sir.
Yes, we will not be able to apply that one because here the projectile is not ground to ground projectile. But can we apply the equation of motion here? That is always applicable, isn't it? So before
Yes, sir.
applying, let's see which is my positive direction. So this is my positive direction and this is our positive direction. Is that clear? This is our initial point. This is our final point. Now look at that initial and final point. If you look at initial and final point, is there some displacement happen in the downward direction? मतलब initial and final point, if you join it, so that will be called displacement. So this displacement has two part, na? Horizontal as well as vertical. So can I write it here? Displacement in y direction will be equal to uyt plus half. Please tell me, what is the displacement in y direction? Is that -100? Please check it and tell me. Is the displacement in y direction is -100? Because from a starting point, the particle has come what? Down. Y direction means vertical direction. Okay. So in the vertical direction, how much displacement happened? In the vertical direction, we have a displacement of 100, but it is downward. So that's why -100. Do we have initial y component? Tell me, do we have initial velocity y component? No, it's exactly horizontal. So initially y velocity 0 plus half. What is the acceleration in y? Minus g into t square. Okay. So if you simplify, what are we going to get it? Under root of 20 we are getting, isn't it? What we are getting? Under root of 20 we are going to get it. Is that clear? So yes, this time under root 20 second we got it. Can we call it this is nothing but the time of flight? Please tell me. What is this? This is the time of flight. Now the next thing, how do we calculate the range? Range means what? How much the particle moved in the horizontal direction. So let's apply it Sx ux into t plus half ax into t square. What is the displacement in x? Which we have to find it out, which I have called it as the range. Initial velocity in x, is it plus 20? How much time the particle has taken? Root 20 into, sorry, plus half. There is no acceleration in x direction. So that part will become what? 0. So that means what is the range of this projectile? 20 root 20 also you can write it 2 root 5 na. So 40 root 5 meter we will get it. Okay. So horizontally it will reach how much distance? It will reach 40 root 5 meter. Of the third part of this question has been asked, what is the velocity when the particle reaches here? Tell me, when the particle will reach this point, will it have velocity something like this? That means in the final situation, can I say particle will have two component of velocity, one horizontal, other vertical. Do you know how much is the horizontal? Is the horizontal velocity still 20? Please check it. Horizontal, no need to calculate it here. Why? Because we don't have any horizontal acceleration. The horizontal velocity will not change. And vertical, how do I calculate it? So to calculate vertical, can I apply it Vy equal to Uy plus Ay into T? Initially, no y direction velocity, acceleration minus 10, time taken is 2 root 5. So am I getting minus 20 root 5 meter per second? That means what? When this particle is about to land on the ground, does it have two velocity? One in the horizontal, which is 20 meter per second, and other one is in the vertical, 20 root 5 meter per second. Please tell me, is this part clear? So what will be resultant velocity?
Yes, sir.
This is the resultant or net velocity, right? So net velocity, if you want to write in the vector form, can you write it 20 in the I cap and 20 root 5 in the minus j cap? So can I write it 20 I cap minus 20 root 5 j cap? This is the net velocity in the vector form. They can also ask you what is the magnitude of net velocity, or they can ask you what is the speed. So what will be the speed? Under root of I cap component square plus j cap component square. Isn't it? We can simplify 20 square, 20 square. So 20 will come outside. It will become 1 plus 5. And 20 root 6 it will come. Please tell me, understood this concept? So you see, if it is ground to ground projectile, we can always apply the direct formulas. Okay, but if the projectile is projected from some height, then what we should do? We should apply the equation of motion, and that will give us the correct answer. Please tell me, is this part clear?
Yes, sir.
Please tell me, all of you are clear about this one? So,
Yes, sir.
right. Okay, understood. So whenever a question will come where a particle is projected from some height, then what we should do it? Then we should apply the equation of motion in x direction separately and y direction separately. And one thing which will be common to both of them is the time. Time is what? Common for both the direction x and y. Okay. Remaining thing we have to calculate it separately. X separately and y separately. Please tell me, clear and clearly understand this question?
Yes, sir.
Now, the last example, let's discuss it here. In this example, what is given to us? Question gave a helicopter was moving horizontally. That question, that concept we have already discussed, but let's see. The question said what? That a helicopter is there and that is moving horizontally with some velocity 20 meter per second. And this helicopter is at what height? You will see that exactly same answer will come, whatever I have given to you in the right now. When this helicopter is 100 meter above the ground, it drops a food packet. Understand? What it did? It drops a food packet. Okay? Means the question says a helicopter moving horizontally. Keep in mind how it is given. It is moving horizontally with what velocity? With 20 meter per second at a height of at a height of 100 meter, drops a food packet. Drops a food packet. They are asking in the question same thing. How much time the packet will take to reach the ground? Where it will land on the ground? Okay. Matlab, what distance from the dropping point it will land? It will not land exactly below na. it will land some other distance. Okay, so at what distance from the point of dropping it is going to land, with what velocity food packet will drop, or sorry, with what velocity the food packet will land. So tell me, whatever I'm going to solve in this question, what is the concept behind it? Tell me. Can I say this helicopter was moving with 20 meter per second? So any object is dropped from that will have what velocity? Please tell me. What will be velocity of the object which is
20
being
meter per second.
exactly same 20 meter per second? So hasn't it? This question becomes like this. The velocity of food packet is 20 meter per second and it is dropped from what height? It is dropped from 100 meter height. Again, it's going to follow a projectile path and it is going to land at this point. Check it. Is this question is same as this one or different? Check it. I took the same data also. Please tell me, has it become the same question? It is like what? A question where a projectile is projected with horizontal velocity of 20 meter per second, not from the ground. It is projected with 20 meter per second from a height. What height? 100 meter. Please tell, has it become the same question? So all these things is asked in this question can be again answered by the same way what we have done it in the last question. So please tell me, understood what we discussed in the 1D and 2D? Please tell me,
Yes, sir.
right? So this is the first unit we had. Okay. 3D motion will come in the electromagnetism part. Okay. 3D motion generally for projectile or these things does not happen. Okay. So 3D motion will come for the electromagnetism part. Like when a particle moves in a combined electric and magnetic field, na, then its path is what? A helical path. Helical path is a three-dimensional path, है ना? Because the particle moves in the circle as well as it moves forward. So those cases we will see the three-dimensional motion. So please tell me what we discussed in the 1D and 2D. Is that clear?
Yes, sir. Clear.
Right. So next, if you see that, we will have what? The next part we will have the force part. Okay. This is your uh,
We can't
entire
hear.
schedule. Okay. Na? Just a moment. Check it. Is it okay? Please check it. Just let me keep it close. Please tell me, is this clear? Hello? Please tell me, is this clear?
Yes, sir.
Please tell. Hello?
Yes, sir.
Okay. Okay. Right. So next we have the this center of mass thing. Okay. And the force. So let's first start with the force part. Okay. And the NLM part we will discuss first. Okay. Clear? Please tell me. So let's start with the now Newton's law of motion, okay, and then the how do we calculate the forces, how do we draw the free body diagram, these things we are going to discuss. Okay, clear? So let's start with the Newton's law of motion. Okay, sequence will be a little bit different what we are discussing. Okay, hello, is that clear? Sequence will be a little bit different here. Okay, your sequentially it is given what? The center of mass calculation first, but center of mass we will learn it before when we are going to discuss about the linear momentum collision. Okay, na? So before learning that one, we will discuss about the center of mass calculation. Okay, right now let's stick to the particles first. Okay, so let's start with the Newton's law of motion. Okay, so all of you please complete 1D and 2D motion now. All of you please complete the one dimension motion and two dimension motion, the problems on that. Okay, please tell.
Yes, sir.
Okay, so now in NLM what we do, up till now you have seen a particle is having initial velocity. Because of that particle displacement happened, particle position change, it got some velocity, isn't it? It has the some acceleration. So here till now we have not discussed anything who is causing the acceleration, isn't it? What is the reason behind acceleration? Do we know what is the reason behind acceleration? We have not yet discussed. So now in this chapter what we are going to do, we are going to learn about that what is the reason behind the acceleration of a particle. Understand? If a particle is having some acceleration, then what will be the reason of that acceleration? Is that clear? That is what we are going to learn in the Newton's law of motion. So how many laws of motion are there? There are three laws of motion. Okay, first law of motion, or you can say Newton's first law of motion. What does it say? It defines about what? It defines about the inertia. Newton's first law of motion, okay, it tells us about what? The inertia of a body. Inertia means what? That if any object is there or any particle is there, right, it may be at rest or it may be in the motion, isn't it? That is the only two possibility. Please tell me. If a particle is there, it may be either at rest or it may be in the motion. There is no third possibility, isn't it? So any object, what is the first law of motion says that any object, whatever state it is in, state means what? Rest or motion. So first law of motion says what? Every object try to maintain its state. It always try to remain in the same state as it is in right now, unless or until we apply some external force in it. External as well as unbalanced force we are applying on it. Okay, so how do we decide which object is going to accelerate more, which object will need more force to change its state? So it is decided by force as well as what? The inertia of the body. Understood? The first law of motion says what? Every object, okay, what is the simple meaning of the first law? Every object tries to do what? Every object tries, okay, tries to maintain its state. Okay, maintain its state. What does it mean by state? Either state means what? Either in rest or in motion. Okay, every object tries to what? Maintain its state either in rest or in motion, unless or until an external unbalanced force, okay, an external unbalanced force is applied on it. Applied on it. Is that clear? So when we apply an external unbalanced force, then only the state of the body will change. Means it can go from rest to motion or it can come from motion to rest. Understood? So again, the question arises that is the same force is needed for changing the state of every object? No, isn't it? See that same force if I apply, the chair can move, isn't it? But the same force I apply, is the almirah is going to move? No, isn't it? Why? Because they have different inertia. Understood? So that's why first law of motion also does what? It defines about it defines about what? It defines about the inertia of the body. Okay, it defines about what? Inertia of a body or of an object. Is it clear? So more the inertia an object has, more difficult it is to change the state, isn't it? So inertia, so it is fine, isn't it? That okay, it has more inertia, it is less inertia. But how do we measure the inertia? There must be some quantity which will measure the inertia. How do I say that this is more? This is having more inertia compared to other one. So the measurement of inertia happens in terms of what? The mass of the body. Understood? So how do we measure the inertia? So inertia is nothing but it's a measurement of what? The mass. Okay. So inertia is what? It is the measurement of what? The mass of an object. So more the mass, we will say more is the inertia. So that's why Newton's first law of motion is also called as law of inertia. Is that clear? The first law of motion? Please tell me. Please tell me. Is the first law of motion is clear?
Yes, sir.
Right. Now let's discuss about the first law. There is no calculation involved in the first law. Okay. The calculation comes from the second law of motion. So what is the second law of motion? Second law of motion says what? That if I am going to apply a force or an external force on the body, what it will do? It will change the state of the body, isn't it? So that's why Newton's second law says what? Whenever we apply a force on a body, external force, keep in mind what kind of force? External force. Whenever we apply an external force on the body or on object, what happens? It changes the state or it creates the acceleration in the body or acceleration in the object. Okay, so in the mathematically we can say that Newton's second law says net external force acting on the body will be equal to rate of what? Rate of change of momentum of the particle. Okay, net external force acting on the body is equal to what? Rate of change of momentum of the particle. So can we also write it like this? Net external force equal to d by dt. Now the question arises, what is the momentum? What is the momentum of a particle? So momentum, we represent it by the p. Momentum is what? It is the mass of the particle into velocity of the particle. So momentum is what? Momentum is a vector quantity. That means any particle momentum will have what? The magnitude as well as the direction of the particle. Okay. So momentum is a vector quantity. So if I write it here, mass into velocity, and if you differentiate it, mass of an object is constant. So dv by dt it will come, isn't it? And see that mass, what is dv by dt? Is this the acceleration also? So Newton's second law, you can write it in the two format. What are the two format of Newton's second law? You can write net force acting on the body as rate of change of momentum, or you can write it mass into acceleration. Both are what? Exactly the same thing. So let me write it at one place. Can we say the net force acting on the body is going to be rate of change of momentum? Okay, or what else you can write it? Mass into acceleration. Okay, is that part clear? Rate of change of momentum, we can write it, or we can also write it what? Mass into acceleration of the particle. Okay, now there is another term we are going to define, that is called, you see, what did you write? Net force. Did you write net force equal time other side? F into dt Can I write it F into dt will be dp? Check it, the dt I have just cross multiplied other side. Now let's integrate both the side. Can you tell me what is this integration of f dt called as? What is the integration of this f dt called as? Can we say integration of f dt is change in momentum? P final minus P initial. And do you know what is f dt is called as? What is the integration of f dt is called as? It is also called as what? The impulse. It is also called as what? The impulse acting on a particle. Okay. So impulse, if you want to act, if you want to calculate what is going to be the impulse acting on the particle, what you should do? You should integrate force with respect to what? Time. That is the one thing. Or what else you can do? You can just calculate the change in momentum of the particle. You can just do what? One thing, simple, is just calculate the change in momentum of the particle. So change in momentum also gives us the same thing. Okay, so impulse or change in momentum are exactly same thing. So if we want to calculate the impulse, what are the method we have? Impulse is again a vector quantity. So if we want to calculate the impulse, what we can do it? Either we can find the integration of f dt, or what else we can do it? We can just find the change in momentum. Is that clear? Please tell me. So what are the two important things we have learned it here till now? This one. Net force is going to be rate of change of momentum, or it can be also written as mass into acceleration. And the second important thing what we have here is this one. Integration of fdt is what? It is called change in momentum, which is also called as the impulse acting on the particle. Okay, change in momentum, or it is also called as the impulse acting on the particle. Once we understand, so one more way we can calculate the impulse acting on the particle. What is that? Let's say, can I take the help of the graph to calculate the impulse? Please tell me. Let's say there is a graph given, force. What is the unit of force? Force is given in Newton. And let's say on the other axis, I'm going to plot the time. Okay? I'm going to plot what? The time here. Time which unit? Let's say SI unit, second is given to us. Please tell me, if I plot a graph and let's say I got a graph like this, can you tell me what is this area of force versus time graph is representing? Can you tell me what is this area representing? Please tell me. Area under the force versus time graph. Does it represent integration of FDT? Please tell me. Area under force versus time graph. Does it represent the FDT integration?
Yes, sir.
And can we call this area is representing the impulse acting on the particle as well? Can we call it? It's going to be what? The impulse acting on the particle also. So sometime what will happen? They will give you the graph between force versus time. So if they give us the graph between force versus time, the area is going to represent what? The impulse acting. Or sometime instead of impulse, they will ask you what is the change in momentum. So we can also calculate it from this area. What is the change in momentum of the particle? And what is the rule about the area? If I say this area is A1, this area is A2, this area is A3, what is the rule about the area? What is the rule about the area? The simple rule about the area is what? Area above the axis we take it positive, and area below the axis what we do? We take it as the negative.
Negative.
Understood? Right? So now let's discuss one two example of impulse calculation, force calculation. Okay, Please tell me up to this part is clear, or let's first write it down. The third law. Third law is again, there is no much calculation about it, but that is still important. What is the Newton's third law? The third law of motion tells us about the action reaction pair. This law is the simplest of all of them in the statement form, but its application is what? It's a very, very large number of application is there. Okay, what is the third law of motion says? In simple, it says every action has what? Has equal and opposite reaction. Understood? This statement, na, we all know that, but when the application part comes, we are all going to make the mistakes. Why? Because there are certain rule about the action and reaction force. Okay, matlab if I'm pressing this palm, these two palms together, what does it mean? On both the palm, equal and opposite force is applied, na? On this palm also some force is applied, on this palm also some force is applied. So equal and opposite force is applied on both the palm. Understood? So these two forces are going to be called what? Action and reaction pair. What is the condition? What is the concept behind action and reaction pair? The first thing is what? Action and reaction pair. Okay, action reaction pair are always acting on what type of body? Are always acting on two different bodies. Understood the first thing? Two different bodies. Means you cannot say that action is also acting on the same body and its reaction is also acting on the same body. Okay? Understood? Like if you are pushing a wall, what will happen? If force on the wall is action, then force on your palm is what? Reaction. Understood? That is the meaning of action reaction force. Don't apply the action reaction force in the same body. Understand the first point? Second thing about action reaction force is what? That these two pair are always of same nature. Action reaction pair is what? It is always of same nature. Is that clear? Please tell me. What is the second point about the action reaction pair? Action reaction pair is always, always of what? Of same nature. Same nature means what? If action is a contact force, right? There are two type of forces, one, some type of forces are contact type, means to apply those forces we need the contact between the body, and some forces are non-contact type, or you can say the field force. Okay, so if action is a contact type, the reaction will be also what? A contact type only. Understood? And if let's say action is a field force means what? Gravitational force is a field force. It doesn't need any contact. Electrostatic force, magnetic force. These are what kind of force? The field force. Okay. So action reaction pair is what? Always of the same nature. Clear? And last point, we all know that it is always what? Equal, and action reaction pair are what? Are always equal and opposite. Means action and reaction pair of forces will have equal magnitude, but they must be acting in what? Opposite direction of each other. So it is always what? Equal in magnitude. Okay, equal in magnitude. And what about the direction? Opposite in direction. The action reaction forces or action reaction pair of forces is always equal in magnitude and what? And opposite in the direction. Understood? These are the three laws of motion, and this entire chapter is based on what? These three laws of motion only. Okay, so Let's discuss few example of impulse calculation or change in momentum calculation. Then we will go for the next part, which is called the free body diagram, where we will learn about how these forces are acting on the body. What are their magnitude? What is their direction? Okay, how do we calculate these things that we will learn. But before that, let's discuss few examples on the momentum change calculation or the force calculation. Okay, let's see an example I'm giving here. In this example, what they give, okay, this is a ground. Okay, this is a smooth ground given to us, and they gave in the question that a ball strikes this ground with 10 meter per second. Okay, and it rebounds with whatever velocity after striking it will rebound na? So it rebounds with velocity only 5 meter per second. Understood? And the mass of the particle is given how much given? Mass is given as something kg given to us. Okay? So they are asking in the question, and one more thing is given. This particle will remain in contact with the floor for some time. Actually, that will be very small time, isn't it? It will be some 0.1 second or 0.01 second, isn't it? It's going to be very small time for which this particle remains in contact with the floor. Understood? So now they are asking in the question, if particle particle remains in remains in contact with the contact with ground for, let's say, 0.01 second, a very small duration it is remaining contact. Then they are asking in the question, first thing you have to find out, find impulse due to flow. Understood the question? Find impulse due to floor. How much impulse the floor applied? And the second thing, okay? Second thing, find it. Moment. Second thing, find it. Find force applied by the floor. Force applied by the floor. Tell me, for the impulse calculation, do I need the time? Please tell me. If I want to calculate the only impulse, okay? If I want to calculate only impulse, then do I need the time? Please tell me, yes or no?
No, sir.
No. But if I want to calculate the average force applied by the floor, then yes, we will need the time duration also. Hai na? That what is the time duration in which this change in momentum of the particle happened, isn't it? So please tell me what is going to be that. Which direction you want to take positive? Let's take the upward direction as what? Positive. Okay. So now please tell me what will be our initial momentum? Can you answer it? Is the initial momentum is going to be plus or minus? Can you just answer it? What will be initial momentum? Plus or minus?
Minus.
Right. So initial momentum is going to be what? The minus. How much minus? Mass is 2 kg and velocity is 10. So initial momentum is minus 20 kg meter per second. Final momentum will be what? Plus, na? Because look at the direction of velocity. Whatever is the direction of velocity, that is the direction of what? The momentum as well, isn't it? So final momentum, if I write it, what it will be? Mass is 2 kg, velocity is 5. So we got it plus 10 kg meter per second. So if I ask you in this question, tell me what is the impulse? Let's say the first part of the question they ask, what is impulse? So to calculate the impulse, should I calculate change in momentum? Change in momentum means P final minus P initial, I should calculate it. Final momentum is plus 10 minus initial momentum is minus 20. So is the impulse acting is 30 kg meter per second. So that is actually impulse. Now if I ask you in the question, tell me what is the force acting due to the floor? The force will be how much? Can I say force is going to be change in momentum by the time taken for that change in momentum to happen? Change in momentum we have already calculated 30. And what is the time duration for which it was in contact with the ground?
Zero point 0.
0.01 second. So am I getting 3000 Newton? I'm getting, just check. Please tell me. Clear?
Yes, sir.
Right? So understood. The simple example that the impulse is going to be change in momentum only, but the force is going to be change in momentum by time duration for that change in momentum to happen. Okay? Of the same question, let me give you in a different way. This example I am going to give you same, but in a different way I am going to give you. Here you see in the question I gave before reaching the ground what is the velocity, and just after reaching the ground when it bounces back what is the velocity, right? Instead of giving you that thing directly, let me give you something like this. A ball of mass 2 kg is there and it is dropped from some height. What height? It is dropped from some height of 20 meter. Understood? It is dropped from what height? It is dropped from some height of 20 meter. And then it will bounce back. So after bouncing back, it only raised up to what height? It only reached up to 5 meter height. My question is again same. Okay? My question is again same. Find first thing impulse. Question is still same. Find impulse acting due to the floor. And my second part of the question is force applied or force acting due to the floor. है ना? At the moment I will ask you the force, I have no other question due to the floor. If it is in contact, it is in contact with floor. Okay. Question. Please tell me what is the difference in the first question and in the second question. In the first question, velocity before striking was given straight away, and velocity after striking was also given straight away. This question, it's not given. What we will do it then? Tell me. So it means, do I have to find out with what velocity it is going to strike the ground? Can I say that this velocity is going to be under root of 2gh? That's what we learn it in the 1D, isn't it? That's what we learn it in the motion under gravity. What will be velocity before striking the ground? Under root of 2gh. Understood? So can I say before striking the ground, its velocity is under root of 2gh. Height is given 20 meter. The question gave the height as what? 20 meter, right? So can we write it? Before reaching the ground, what is its velocity? So under root of 2, g, let's take it 10, and height is given 20. So can I say before striking the ground, its velocity is 20? after striking the ground, with what velocity it will rebound? So maximum height is given, isn't it? Maximum height is given to the question. So if maximum height is given in the question, can I again find out what will be the velocity now? Isn't it again a case of what? Motion under gravity. And h max is u square by 2g. So can I again use it here? 2g into h max. Please tell me. So under root of 2, g is 10 and the maximum height is 5. So what is the velocity I got it? 10 meter per second. So that means, can I solve this question further? Can I call, and I'm going to take this direction as positive in this question. So tell me, is it going to be my initial momentum 2 into 20? Will it be negative because of the direction? So minus 40 kg meter per second. Final momentum, how much it will be? Plus, mass is 2 kg, velocity is 10. We got it, plus 20 kg meter per second. So it means what is going to be our impulse? Means impulse due to the floor. It's a vector. So what it will be? P final minus P initial can be written minus 40. What we got it? Plus 600. And if they ask it, what is the force applied? Then can we say force applied is going to be change in momentum divided by the time duration. Are we getting 6000 Newton? Please tell, understood this one?
Yes, sir.
Please tell me, understood this question? So both question are exactly same. First question, the data of velocity before and after directly given. Second question, instead of giving you directly the velocity, they are asking us to apply the motion under gravity concept to calculate the velocity before and after. Understood?
Yes, sir.
Let's discuss another example, a different one. And the question gave something like this: a wall is there to us, and this is the line. The question says a particle, okay, the question says a particle is going to move with what velocity? 10 meter per second at an angle of 30 degree. After striking, what happened? It bounced back. Let's take the same 10 meter per second and same angle 30 degree. Okay. You have to find out what is the impulse only. This time only find the impulse. So if they are asking me in the question, only find the impulse, that means change in momentum is enough, isn't it? For impulse, is the change in momentum is enough? And for the force, change in momentum by time will be needed, isn't it? So please tell me what I should do it here. Mass of the object is 2 kg again. Okay. Let's take it 3 kg again. Please tell me what I should do it. Can I make it like this? Is this my initial velocity? Please check it. Is the initial velocity is making 30 degree with horizontal? So initial momentum, is the initial momentum is going to be mass as 3 kg, velocity as 10. So 30. But here, one direction is not involved. Here, two directions are involved in the calculation, isn't it? So if two directions are involved in the calculation, I should bring I cap and j cap in my question because I have to write a vector, isn't it? A vector has both magnitude and velocity. Okay, so that's why it is always better to write it what? In the I cap j cap form. So can we say my initial momentum is 30 cos 30 this component and 30 sin 30 this component. So if I write my initial momentum, will I get it 30 cos 30 with I cap and 30 sin 30 with minus j cap? Please tell me, is this part clear? Now let's go to the final one. Is the final velocity is like this? Mass 3, velocity 10, so it's still 30. This angle is what? 30 degree. What are the components going to come now? Is the component is 30 sine 30. So if you write your final momentum, what you will write? Will you write it minus of 30 cos 30 that goes in minus I cap and 30 sin 30 that goes in minus j cap. Please tell me, are P final is done. Can I write it? Impulse will be equal to this. Please tell me, are you clear what we discussed till now? So these are just the application of what? Your definition of the momentum and impulse. Okay. So tomorrow we have the class at the same time. We'll discuss about what? We'll discuss about what are the different type of forces and how to draw these forces in the free body diagram. So please tell me what we discussed till now understood or still confusion? Anything is there? Please tell me.
No, sir.
Please tell me, all of you.
Understood, sir.
Sharan, Lokesh. Right. So let's continue same time, okay, tomorrow, and we'll continue from here. Okay then. Thank you so much. Take care everyone. Good night.
Thank you, sir.